Okay, so
You have to pick pencil.
oh,
Yeah, there you
because b equals 0, I had to think of uh, two different numbers that add to 0 and multiply to negative 36. And so the two different numbers need to be opposites of each other, so I just thought of the square root of 36 and thought of 6 and 6. So because it's negative, it has to be 6 and negative 6. So yeah, it's x plus 6 times x minus 6. And then x just equals negative 6 and 6.
The only thing that I would ask you to do is, you guys notice that in the green, the x plus 6 and the x minus 6, can somebody classify what that is for me?
I think it's difference of perfect squares.
Yeah, it is a difference of squares, but I'm asking you in particular, in red, in orange, and in purple, what are those three things?
Trinomials?
They are equations, right? In green, what Aritro wrote is not an equation. That is an expression. You can't solve expressions. I know it's a very small thing, but you must keep equations when you're solving. So you got to keep it equal to 0. That's something not just for this particular lesson, but for every lesson, especially when you get to AP and SAT questions. You have to keep those small details to get full credit on open-ended questions. So I'm going to ask you guys to be a little bit more precise with what your work is, even though the answers aren't incorrect, they are right. That one little piece would be something that I would be looking for that you keep in your problems. Okay? All right. Nice job.
For this, could I just say plus or minus 6?
You can just say plus or minus, but that's also okay.
Okay.
All right. Last problem. Luca?
You said that this was correct, right?
We're going to find out.
Should I erase that?
No.
Okay.
Hit the four. I don't even know what you call it. Like
Cross.
the cross.
This?
Yep. And then you can just move it over to the left when you have more space. There you go.
Okay, so since that is bigger than 1, you have to do it differently compared to the other ones. So first, I just did this. So I set it equal to 0.
All right. So the first step was set it to 0.
Yes.
Okay. What's step 2?
This part.
Okay, go ahead.
So I figured out that the two numbers were negative 12, both of them.
12 and negative 12. Okay.
And then next I make my box. And so A will go here and C will go here. So in this case it was 2x squared and 72. And then in those two boxes you would just put the two numbers that you found.
Where'd you learn this?
On YouTube.
I didn't teach you this.
Well, it worked, right?
It does work.
So then
Well, she looked it up.
I didn't know what to do, so I watched the video.
That's okay.
So then you can just kind of go backwards.
Whoa, stop, don't say that. We don't just go backwards. That's not what we do.
Well, I mean compared to normally you would go
No.
that way.
So you watched the video, right?
Mhm.
Alright. Everybody follow what Luca did so far. Step 1, set it equal to A. Step 2, multiplied A times C and found the number that multiplied to that and added to negative 24. Then in the box is if we were going to multiply something out. So you take what you have in your x problem and it goes on the diagonals. Now, to get the outside of that box, it's really simple. It's the greatest common factor of the rows and the columns. So 2x squared and negative 12. There should be an x on that 12 at the bottom.
Oh.
They share 2x as a
Mhm.
factor.
For this?
Now, the next row has what as a factor?
12 or negative
2x
12?
and 12 is 2x again. So take out another 2x on the left-hand side.
Is it just x?
Nope, it's 2x. Each one of those should have 12 as a factor, negative 12. So take out negative 12 for both. No x.
Wait, what? I'm confused.
I know. 12x and 72.
Mhm.
That row. Well, that's a column. The row.
Oh. There.
They share just 12.
Mhm.
So take out a 12. Put 12 out there. And 12 and 72 share 12 at the top too. Okay. Now, that's not what you have written down, is it?
No.
I know. So, in order for that box method to always work,
Mhm.
we have to use GCF. That's just our process. Otherwise, what you did, I think, was you just found numbers that made it work.
Mhm.
But what if you can't find the numbers to make it work? We need a process to be able to fall back to. And that's the greatest common factor.
Okay.
So, in this case though, did it work?
What I did?
What I did?
Yes.
No.
Oh wait, no.
What you did
What I did.
What I did didn't work. Why?
It's not factored completely?
It is, but it's wrong. Only because, what's 2 times 2?
4.
So that didn't work. What do you have? Can you draw another box and show us what you have, please?
Yes.
And we're going to talk about what happened. Why mine's wrong and why yours is right.
Yeah, Alex made me do that. I couldn't figure out how to do it otherwise.
This is really
I figured out the last model. Even though I think
this back there. My little key ring got all bent. And then what's coming off? So I'm gonna have to take that together.
Okay, your method is really interesting.
You're going to sell it. How about probably got stuck in something. Okay, I'd like to go over this and think about. Can you move it down a little bit? No, I mean like so we can see both boxes. Yep. Okay. Guys, very first step that Luca did. Can you underline it? Setting it equal to 0, please. Yeah. Pick a different. Yep, there we go. Right there. First step is correct. Second step should be to do what? Factor out your GCF. Now, some problems it'll work out. Luca did not factor out the GCF, still worked out the problem, but explain how you got your box.
So I knew that this was A and this was C, and I had already found those values. So I just, since 2x and x, you get 2x squared, and then that as well.
So you just started picking numbers that would fit into the pattern.
Mhm.
Okay.
And then I got my answer 2x minus 12, that's the first set, and then x minus 6.
The only problem that I have with this, and the reason why this one worked out well, is 2x squared. What type of number is 2?
Even,
Even. More importantly, 2
prime.
is prime. So there was only one way that you could multiply to get 2x squared with integers. It
Mhm.
was with 2 and 1. What happens if that number is 18?
It would not work.
It could be 1 and 18, could be 3 and 6, could be 6 and 3, could be 2 and 9. So now you've got to do all the different problems,
Mhm.
and it can start to get a little bit more complicated than that one. So what you did works, but I would ask you to always check for GCF
Beforehand.
beforehand. Because what happens when you check for GCF? Those of you that did GCF first.
It's easier, I would say.
I don't want to say it's easier, but when you get down to it, we're going to get the same answers. This is perfect. You did fine. I'm just cautioning you that
Yeah, I
because that's prime,
couldn't
it
do
worked
that
out
for
nicely.
everything on the
If it
Alex.
doesn't, if it's not prime, it doesn't always work out like nicely.
Mhm.
So it's great, but we want to be careful. If I take out 2x squared minus 12x plus 36 equals 0, and now we're going to factor what's inside. So what multiplies to 36 but adds to negative 12?
Negative 6 and then 16. Yeah, that's what I. So that's similar to the last equation.
So if we solve this problem here in green and we solve our problem up here, we still end up with the same answers, which is x equals 6. How many times did that happen?
4 times.
I'm going to say x equals 6. That's not what I
What
want.
is it DR stand for?
I'm going to write it down.
Dominican Republic.
Double root. Guys, how many times is that going to touch the x-axis? Once. So when we factor, remember, how many times can a quadratic touch the x-axis? It could touch 2 times. It could come down and touch once, or the graph could actually be above and have 0 real answers. So when we are trying to factor a quadratic, if it factors and we get 2 real answers, it'll look like something like the red graph. We factored here, we got 2 answers, but they happen to be the exact same number. That means it's going to look like the green graph. It's only going to touch the x-axis once. If we get an equation that is like the orange graph, you won't be able to factor it. They're not factorable. You will never find real numbers that would make that case happen. Okay? In that case, we have to use something called the quadratic formula or completing the square, which we'll get to in another lesson. Questions about this problem? Okay.